Hey, physics, it's Lipkin, and today I'm going to talk about some of the problems for the lessons on forces lessons. All right, and so the first problem is where we have a student who's going to be leaning up against a wall for us. At any rate, and you're asked to draw a free body diagram. Now here is a scale on the ground, okay, and here is our student volunteer. Now go ahead and stand on the scale at this point and just hold this to his forehead, and at this point he's not leaned over, so we know that he's at 0 degrees. He's standing vertically and he's at 0 degrees. And now he's going to lean over and support himself on the desk, okay, and actually go ahead and kick this back a little bit. Let's go back like this. Go ahead and now we want this thing. No, I can't see. Okay, he's at 20 degrees right now. All right, so he's leaned over by 20 degrees. You can do the problem as it's written at 30 degrees, or you can actually do 20 degrees. The point is of course, the scale on the ground should change its value from 100 pounds when he's just standing on it to what is it now. All right, at any rate, you're supposed to draw a free body diagram for the bathroom scale. All right, thank you. Hey physics, so here we wanted to talk about, I think I did this in the wrong order. I think this was 3, 4, and 5. But you have a mass on a table like this, and then the mass is being pulled by a cord, and it's being pulled by a weight over there. Now Anna is going to show us, or keep adding mass until the mass starts moving, okay? So go ahead, Anna.
100, 200, 300, 350.
Okay, now that's a total of 400. Go ahead, and you can see it just started moving. Okay, so that's where we got our 400 from for this problem. Was 400 grams was just enough to start that moving. Okay, so and then the last one would be if we have this thing up in the air 20 high, okay, which it is right now, okay, and we're going to have to get a longer rope, and we're not going to show that right now. But if we put 1,200 grams, which should clearly be enough to get this thing in motion, how long will it take it to impact the ground? How long will it take for that 1,200 grams to reach the ground? That's our second lesson question, okay? All right, good luck with that. Hey, okay, so for number 2 on the forces lessons, what we have here, I've set it up for you. You have 350 grams hanging from this weigher scale. That's a spring scale. Okay, you notice that the mass is not resting on the pan balance. I put this flask on the pan balance, and it says 142 grams. Okay, now I add, this is 500 milliliters of water. Of course, it's 250 a piece. Okay. Actually, I'm just going to put in 250 milliliters of water because that's enough. All right. Now, the mass is actually immersed in the water. Okay. And then the water's in the beaker on the balance, on the pan balance. Okay. You draw a free body diagram of all of this, but you need the free body diagram to be able to answer, what's this read? Okay, what's this scale read? That's the spring scale. What does this scale read? The pan balance, what does it read? How would those two be different? Okay, at any rate, you need to have all of that in your free body diagram. But here's the thing that is not probably that immediately obvious, which is there's also going to be a buoyant force involved, isn't there? At any rate, the buoyant force of the water lifting up the weights. Anyway, shouldn't this have read 150, well, it was 350 grams. This should have read 350 grams before I submerged that mass in water. Now that they're submerged in water, it shouldn't read 350 grams anymore, should it? At any rate, so do a free body diagram to be able to determine or see if you could determine the buoyant force of the acting on those masses as they're suspended in the water. But at any rate, here I thought this would help to be able to visualize that problem too. But this is what it is. Okay, that we have a mass here that's suspended by a spring balance up here, and part of the weight is being taken over by the water and the buoyant force. I wonder where that weight is going. I wonder if there was any way I could measure that directly.